Hello everyone. So basically, your normal crypto explorer lets you see transaction on the blockchain, but privacy coins like zcash limit you from doing that. This is because zcash shaded transactions are encrypted in such a way that they appear as like an opaque blob on the blockchain. So even the sender can't easily verify their own transaction history without running a full node. You get, but current solutions require either exposing your viewing key to a third party or running a complex wallet software. Neither of these is ideal. So we now built Zcash Shielded Explorer, which is a privacy-first block explorer that lets you decrypt and analyze your shielded transaction without exposing your viewing key to anyone. So here is how it works. Your viewing key never leaves your browser. All encryption happens locally in your system using WebAssembly compiled from Rust, which is obviously the same cryptography library that most Zcash wallets use. So now the backend only provides the encrypted transaction data. It never sees your key and it can decrypt anything. This is trustable privacy, and I'll prove that in a minute. So now you can see it actually supports both testnet and mainnet, but I will only be showing you proof with testnet because I have no fund to actually make transaction on the mainnet to actually show you that it works. So I created some um testnet wallet and run transaction with it using single CLI. So here is, let's check with the first key. Is decrypting now. Oh, sorry, just give me a sec. I need to refresh this. Pause the video a sec. Okay, just finished decrypting. As you can see, it decrypted one, two, three, four transactions I actually did here. Here is my first transaction when I requested some testnet token from testnet.segfacet.com, and it actually decrypted the memo. Normally, this is supposed to be encrypted too and can only be accessed by someone who has the VN key. Obviously, you're the receiver. So it also decrypted it. We also added it to be able to show information like each type of transaction, which in this case is a shaded transaction from an orchard pool, have several confirmation, date, time, even block, and the amount. Here it can show you the output here, different transaction, because this was basically me sending it back to myself. I was making transaction. I didn't have anybody to actually send it to, so I was sending it back to myself. So that's why these are the two transactions happening here. You can see two outputs. So and we also added some other better user interface features like exploring and searching some transaction by their transaction ID. So basically, we actually this is meant to decrypt all your entire transaction, assuming we are running a full node, because normally we are not actually running a full node currently. It's running on a Tatum API, which gives us 300k API calls. We don't really have the fund or resources to actually run a full node, but the code is correct and everything will work if we implement a field node, which is what I'm trying to prove right here. You get, so you can actually sign try by transaction type. Forgot to add, to actually run a full node you need about 100k 100 gig disk space, which we don't actually have even on this PC right now. So that's why we're relying on API endpoints to prove that everything can actually work. So you can search by transaction type, is issued, they're not transparent, and the rest of them. You can search by the range of the ZEC in the transaction, the amount. So apart from that, here is another cool stuff we added, showing the charts. Here you can see your cumulative value over time, You can see a transaction type and the volume you have to actually transacted in terms of transaction types, obviously. So you can actually import, export using as a CSV format or JSON format. We also added some privacy analysis. As you can see here, 3 transactions within 1 hour. Normally, if you are doing transaction concurrently, it can actually be traced by blockchain analysts if they check the timing. Although shielded transaction should be able to give you some shield, but a cracked dev that can actually decrypt this can actually pinpoint it based on the time-based analysis. And also round amount, as you can see, everything is ending with 0000, which is almost it can sell you out sometimes. It's best you add numbers, complex numbers at the end, so that it will remain undetectable. We also give recommendation to all these flaws, but the privacy is still strong about it too, based on our scoring. So, and that's it for here. So let me try one other. Oh, give me a sec. One other viewing key. I didn't have much transaction here, but this is just to show you that everything actually works. So it's decrypting. In a minute, yeah, here it was actually one transaction I sent to myself. Obviously, you can see everything is actually working as intended. And to actually prove that all this is working only on your local, let's check our console. Sorry, but let's go back. It doesn't give away any of your information. So here is where one of them started. It received the branch ID, it passed it. Here you can see the transaction first. It's calling for a decrypt. Then at the end of everything, the decrypt transaction returned. Or you can see area 1, length 0. Nothing valuable was actually returned that can actually be linked back to you, or that can actually take your information. Everything is running locally and no privacy is complicated here. Let me find another transaction. You can see it here. Nothing. So that's all for it. And we can actually push this to deployment because we can't actually, like I mentioned earlier, we can't run a full node. We don't have that resources. It's relying on API. So probably if we win the bounty, we'll consider running a full node so that everyone can actually view their transaction. Because us pushing this to deployments, we have to index the entire zcash block, which is a lot, and Tactum API 100k free API calls won't cut that for us. So we basically rely on full node to actually give everybody the opportunity to do that, but that requires a lot of resources and funds to set up. So for now, this is all I can provide. A demo video that explains how everything works. The code is solid and everything will work. Thank you for watching.